Okay, guys, so far we have seen how to draw the graph of y is equal to a sine x plus b. But you know that this a is the amplitude, okay, and this b is the axis of the curve. Okay, this is the axis of the curve. Now we're going to add, like this is the final version of the sketch. This is going to be y is equal to a sine bx plus c. Now this means that now we can have a composite, a compound angle over here, okay? And the angle will no more be a simple angle. So what will happen to the curve when you have, for example, you can have, I'll be starting with the y is equal to sine 2x, the simplest case, okay? Or y equal to sine 3x or y equal to sine half x. Now, before I tell you the sketch of this y is equal to sine 2x, I need you guys to remember that remember when we were solving the equations like this of sine 2x that is equal to 0.5, okay? Suppose your x was between 0 and 360. So what did I tell you that when you have the composite angles, how to deal with that? Anyone? No one remembers? You were told that this 2x had to be changed with the alpha, okay? And now this sine x, sine 2x, so this equation will now change into sine alpha that is equal to 0.5, okay? And now you will also tell that what are the limits for this alpha. Guys, haven't I told you about this? This is 0 and this is 720. Please you say yes or no. Guys, bacho, don't you remember how to solve this equation? Hello?
Sir, we do.
Yeah, I have told you about this. I remember, like this is going to be 30 here and this is going to be 30 here, okay? Now this alpha is going to be 30, 150. We'll go up to 720 now, okay? So this is going to be 390 and this is 510, okay? So we're getting 4 values of alpha because the revolution has been doubled because of this 2x over here, okay? Now when we find the values of x, x would be half alpha. So the values of x are going to be, this x is going to be 15 degrees, 75 degrees, and then 195 degrees, and then 255. Yes, this is 255. So this means the graph should also show 4 values of x where y would be equal to half if you draw this sketch over here, okay? Now, how would you manage to show 4 times this y being equal to half? So look at this. I'll first show you the graph of y is equal to just sine x. Oh, sorry. Um, so now when you have y equal to sine x, bacho, look what happens. This is your 90, this is your 180, this one is 270, and this one is 360. So the sign goes like this: x's, maximum, x's, minimum, x's, okay? And look at the graph here. This is going to be the graph. Okay, if I draw here just to show you half here, okay, you see that you're getting half at two of these points here. One is obviously, this one is obviously 30 degrees, and this one is going to be 150 degrees. So we have to draw a curve here for this sine 2x, where this curve should show y equal to half four times at all these values. So how would we manage to show this? Now look at this, how you will be doing this. You will, this is 90, you will just divide it the same way as you were doing before. Remember, you will always start marking this after every 90 degrees. Okay, now this is your 360 degrees here. Here you have 1, here you have -1. So when you see that this is 2x over here, you further divide these intervals into two parts. Like this is going to be, we see this is the new thing for you guys. Okay, you divide this into further two parts. This is 45 90, this is 135, this is 225, and this is going to be 315. Okay, and just follow the same rule. I mean the flow. This is the x is maximum, x is minimum, x is maximum, x's minimum, and x's. Okay, so here we have the curve. Okay, so guys, if I show you the half thing here, like suppose here you have half. Okay, so you see that if I draw this dotted line to show this is not the x, half. Okay, how many times you have this horizontal line passing through this graph, through this sines graph?
Four.
Four times. You see, this was two times here when this was simply y is equal to sine x. Okay, and now this is four times. Guess what should be this value of x here? What should be this value of x here? What should be this, and what should be this? Doesn't this value look here to be 15 degrees, Anna? And this value over here, this looks to be 75. This value is looking to be 195. Hannah, Pacho, please tell me, Hannah, are you
Yes, sir.
understanding this? So this one is going to be 255. Okay, so remember, I'm going to repeat it. Okay, I'm going to repeat this. Whatever is the angle over here, you will always start by marking your horizontal axis after every 90 degrees. Okay, after every 90 degrees. Now, if you will have to show that x is the amplitude, whatever you have there. Okay, then how to handle this angle over here? If your angle is 2x, you will divide these intervals into two parts. Suppose you have y is equal to sine 3x. Suppose it is like this, y equal to sine 3x. So now you will divide these initial divisions into three parts. Look at how I'll be doing that. This is like I'm dividing them into three parts. So equally, I'll mark 2 points. Okay. So like when I divided this into two parts, you have to see that what is half of 90? That is 45. Okay. So 45 plus 2 times 45, 3 times 45, 4 times 45, 5 times 45, 6 times 45. Look at this, how I'll be writing over here. What is 1/3 of 90? That is 30. So this is 30. 32s are 60, 33s are 90, 34s are 120, 35s are 150, 36s are 180, 37s are 210, 38s are 240, 39s are 270, 3010s are 300, 3011s are 330, and 3012s are 360. Okay? Now, suppose, let me add some spices into this. Suppose the equation is y equal to 3 sine 3x and plus 2. Suppose it is like this, okay? So this is going to be 1, 2, 3, 4, 5. So you have the x's at 2. Okay, x's at, this is the x's here. Okay, so I'll be showing the x's through a dotted line. Okay, then this is the amplitude. So 3 up from this 2 is 5, and 3 below from this is going to be -1. Okay, once I have done this, now I'll be the flow. Okay, so this is going to be x's maximum, x's minimum, x's maximum, x's minimum, x's maximum, x's minimum, and x's. Okay, so here is going to be the graph. Look at this. Look at this graph here. Here is the graph like that. Do you see this? How this graph has been sketched? Okay. Now I should tell you that what does this B represent over here, okay? You know that A is the amplitude, I mean this C is the axis here. What does this B represent, okay? Now remember, this B tells you about the period of the function. This is the first time I'm using this word here in this lesson, the period of the function, okay, of the graph or the curve, okay. You see that period means that is the time interval, the interval in degrees in which the your curve completes one wavelength is completed. Now, what do we mean by one wavelength? That means, for example, look at this. This is the position of the curve here. Let me use a different color. This is the position of the curve here, and this is. Okay, there was a problem in the net, so I have to draw all these curves again for you guys, okay? Now, you see that when I have these three different equations, one is sine x, the other is sine 2x, the third one is sine 3x. So whatever is the angle, I will always start by taking the intervals of 90 degrees. That is what you need to remember, okay? Now, when you have here the just sine x, so no problem. We have marked the maximum, the minimum thing, okay? So this is the x's, the maximum, the x's, the minimum, and the x's, okay? So the curve goes like this. I'm just going to take it up to this. I have to tell you about the period thing, okay? So this is, let's say, 450 over here. And if I take it up to this, let's say this is -90 over here, okay? Acha. Now for this, when you have sine 2x over here, you will divide these intervals into further two parts, okay? Now this would be 45, then this is going to be 135, this is 225, and this one is 315, okay? So you have 1 here, you have -1 here. And remember that flow for this curve, this would go like this. X's maximum, X's minimum, X's maximum, X's minimum, X's. And here is the curve for this. This is going to be like this. Oh, come on. Okay, this part is really drawn very roughly here. Okay, so now look at this one. This is the 3x over here. So I need to divide this into three parts, guys. This is going to be divided into three parts over here. Okay, so this is going to be 1/3 of 90 is going to be 30, and then you keep on reciting the table of 30. Okay, so this is 120, 150, 180. 210, 240, this is 300, this is 330, and here I have the maximum 1, here I have the minimum -1. Okay, well, let's draw this curve. So this curve is now going to be, again, the same flow, x's maximum, x's minimum, x's maximum, x's minimum, x's maximum, x's minimum, x's, okay? So this curve should look like this. So here is a curve. Okay, I was telling you that this when you have y is equal to a sine bx plus c, so this a is the amplitude. Okay, this is the amplitude of the curve. This c is the axis of the curve. Okay, and now this B, what does this B tell us? This B is going to tell us this is going to be 300 over 60, 360 over B. That is going to be the period over here. Okay. Now, when it was just sine x, so the period is going to be 360. Look at this. It is at the maximum value at 90 degrees, and it is again at the maximum value at 450. Okay. So how many degrees difference is here between these two? So that is 360 degrees. You can even look at this value over here, this minimum and this minimum. So what is the gap of values here of the, how many degrees are gone by? This is 360 degrees. Okay. Now, if you look at this one, look at this maximum value and this maximum value. This maximum value is taking place at this 45. This is happening at this 225. So how many degrees difference is there? Yes, bacho. How many degrees have taken place here?
180.
180 degrees.
180.
So that is basically 360 over 2, that is going to be 180 degrees. And if you look at, like, these two over here, what is the difference in these 2 degrees over here? This is 150, this is 270. So that means this is going to be 120 degrees. That is basically 360 over 3, that is 120 degrees. Okay, so you can take the screenshot here. So we have completed our sketching of y is equal to sine x and cos x. We started from, let me tell you again, we started from y equal to sine x. We moved on to y equal to a sine x. Then we moved on to y is equal to a sine x plus b. And finally, you have seen, we have seen how to draw the graph of y is equal to a sine bx plus c. ठीक है बच्चों? So up, let's say you have to, you are required to draw the graph of, let's say, uh, y is equal to 3 cos 2x minus 2. Please try this sketch. Let's draw this quickly. So first of all, whatever is the equation for the sine and cos, we'll always have the intervals of 90 degrees. Remember, okay? The next thing you have to show is the axis. This is here at -2, okay? The next thing is you have to show the amplitude, okay? The maximum is 1. This is going to be 3 below this. It is -5. And then you adjust this angle here, okay? This is divided into two parts. I'm not going to show that, that is not even required. Or you can write this if you want, okay? So you start from the maximum axis, minimum axis, maximum axis, minimum axis. Okay, so here is the graph for your uh, this. I'm going to start this from here. Okay. So this doesn't look a very nice kind of a curve, but anyhow, you can forgive me for this because it's really the end of the lesson. Okay. So guys, I hope you got it, how to draw the graph of y is equal to a sine bx plus c, or y is equal to a cos bx plus c. Thank you very much.